Iloilo Science and Technology University, La Paz, Iloilo City, solar cells efficiency increase using thin metal island films. A scientific journal presented to Engineer Pincy Roy Carag, Iloilo Science and Technology University, La Paz, Iloilo City, in partial fulfillment of the requirements for the course ECE 31 Industrial Electronics Lecture by Rachel O. Erasga, Marcian C. Gonzalez, Shelo D. Hacolina on November 2022. Solar cells efficiency increase using thin metal island films. Introduction. The sun has immense energy potential, but due to a reduced amount of efficiency of the cells, it is mainly a difficult task to extract electricity from it. Muhammad et al. 2017. In the research article Solar Cells Efficiency Increase Using Thin Metal Island Film, Alexander Axlevich and Gary Golan, June 10, 2013, investigate the possibility to increase the solar cell efficiency through introduction of gold island film between the emitter and base of a silicon semiconductor diode structure. Dr. Alexander Axlevich is a programmer technician at Professional School of Leningrad State University in Russia, 1965. He is also an electrical engineer and electronic engineer, BSCC and MCC at Electrical Engineering Institute of Leningrad, Russia, 1971, and a PhD of the Faculty of Electrical Engineering, Physical Electronics, Tel Aviv University, Israel 2002. Dr. Alexander Axlevich has a wide experience in experimental and applied scientific research in the field of thin films technology, semiconductors, and renewable energy sources. Gary Golan is professional of electrical engineering at Ariel University in Israel. In 1990 to 2010, Professor Gary Golan is head of the Microelectronics and Thin Films Laboratory at HIT and authored more than 150 scientific papers and numerous abstracts and scientific meetings. He also authored two academic textbooks, Semiconductors and Semiconductor Devices, at Open University Press, Israel 2002. Relevant to their educational attainment and achievements, Dr. Alexander Axlevich and Professor Gary Golan are already informative about solar cell efficiency and thin metal island film, which is what the research article is all about. The use of thin metal island film to increase the efficiency of the solar cell is possible as this metal has the ability to generate plasmon polaritons under light absorption along with its energy compatibility with the semiconductor surrounding the metal islets, and this metal has an opportunity to create a Schottky diode in contact with the semiconductor. These abilities of the thin metal island field are ideal for solar efficiency increasing as it is the standard in choosing the best type of metal used to conduct this study.
Axlevich and Golan introduced a thin metal island film to be used to examine its suitability for increasing the solar cell efficiency, as there were standards on what type of metals should be used based on the properties or abilities of a metal. The researchers used different formulas to further expand the information regarding the study that is relevant and support the claims on the possibility that the solar cell efficiency can be increased. Using the formulas below, Axlevich and Golan found out that the solar efficiency increases. This research article included the parameters of the solar based on the single crystalline silicon. The built-in voltage in the depletion region of the photovoltaic cell is described by the well-known relation where V sub B equals to V sub T ln of N sub A and N sub D over N squared sub I, where Vt equals to Kp over Q is the thermal voltage. K is the Boltzmann constant, T is the absolute temperature of the environment in K, and Q is the electrons charge. N sub A and N sub D are the impurity concentrations in the base and the emitter, respectively, and N sub I is the equilibrium intrinsic concentration of charge carriers. Due to sunlight irradiation, additional charge carriers are generated in this structure and produce electricity. Efficiency of such conventional PV cell is defined by the incident power, P sub IN, semiconductor properties, and the quality of electric contracts. N is equals to P sub M over P sub IN equals to I sub M, V sub M over P sub IN equals to FFI sub SC, V sub OC over P sub IN, where P sub M is the maximum produced power, I sub M and V sub M are the maximum produced current and voltage respectively, I sub SC and V sub OC are the short circuit current and the open circuit voltage respectively, and the FF is a fill factor of the PV cell. Maximum efficiency of such one-junction solar cell cannot exceed the Shockley-Queisser limit, depended by the band gap, width, and the semiconductor quality. Maximum produced current may be calculated from the basic Shockley equation. This current is described as a function of the generated current, I sub L, where I sub efficiency of the cell may be increased by increasing the generation current or at the expense of increasing the electron flux generated by PV cell. The excess energy is lost as heat and cannot be converted into useful electric power. Moreover, this heat decreases the PV cell efficiency due to thermal generation of intrinsic charge carriers. Full addition currents which should be obtained due to inserting the metal island film into PV junction may be estimated as a sum of currents introduced by each island in the following way. I sub AD equals to A sum of S sub J and J sub NJ, where J sub NJ is the current from the metal island, J is an index, N is an average number of metal island per unit area. S sub J is an average contact surface area between the metal's island and emitter. And A is the active surface area of the PV cell. Therefore, the maximum generated current will take the following form: I sub M equals to I sub L plus I sub AD, where V sub T over V sub M times the negative 1. Calculation of efficiency of the novel PV cell shows an increase in efficiency of 17% and gives 17.5% instead 15% without the gold film. This result agrees with the experimental data where efficiency of organic solar cells based on the bulk heterojunction system with silver nanoparticles was increased by 17%.
Critical evaluation. The researchers conducted a study that helped to reduce fabrication costs and increase efficiency of photovoltaic devices, as solar cells have potential to replace fossil fuels as the main means of electric power generation. However, solar cells of all types suffer from two main deficiencies: relatively low conversion efficiency and high cost in comparison with conventional fossil fuel electric sources. The article falls under the design of experimental research as it uses scientific methods such as calculating the increase of solar cell efficiency and in the mechanism of increasing efficiency. Qualitative analysis is being chosen. The researchers showed that the Gold Island create a set of elementary Schottky diodes. These diodes are in forward bias condition due to its built-in electrical field within the emitter-based diode structure. These Schottky diodes can inject the free electrons excited by sunlight irradiation in the conduction band of the semiconductor, and by this way increase the maximum current generated by the solar cell. The tentative calculation done on a standard solar cell showed an increase of efficiency of 17.5%. Therefore, the purpose of this study is achieved and the result is in good agreement with experiments. Alexander Akselevich and Gadi Golan Holland, 2013, presented the work objectively and the search of ways to reduce fabrication costs and increase efficiency of photovoltaic devices that serves as the main goal of researchers is achieved as the efficiency increased to 17% by using a thin metal film. It can be clearly stated that possibilities of thin metal film in increasing efficiencies are working, and there are claims that proves that the possibilities, the first one consisting in combining semiconductor photovoltaic converts with suitable heat absorbing bodies, that is water or oil from heat them and use this thermal energy. The second method to improve efficiency is based on utilizing various semiconductor materials in order to enlarge the spectral efficiency. Multi-junction devices or heterojunction devices can reach larger spectral efficiency by capturing different parts of solar spectrum. A multi-junction device is a stack of individual single junction cell in descending order of band gaps. The top cell captures the high energy proton and passes the rest of protons onto the absorbed by lower band gap cells. Consecutive combination of 36 junction may attain an ideal efficiency of 72%. The main problems in establishing such PV cells are high technological complexity and high cost, respectively. The third method we have in mind is to increase efficiency in is using hot electrons that generate charge carriers with energy that is higher than the semiconductor band gaps. The efficiency may be increased only using low dimensional structures such as quantum wells, quantum dots, or nanocrystals above 5 nanometer sizes. Thin metal island films represent another low dimensional structure, as known. Such thin films built from several types of metal have interesting property. In response to light exposure in a certain spectral range in the island of metal occurs resonant absorption of light. This phenomenon can be fixed by the appearance of localized plasmons polaritons with intensity and frequency that are relative to size of island in the film. The metal nanoparticles are utilized to provide extra scattering in order to increase the efficiency of photovoltaic cells or for the enhancement of photovoltaic devices by using the surface plasmon resonance within the visible and near visible spectral range. So, in conclusion, Alexander Akslevich and Gadi Golan, 2013, shared encouraging results of increasing solar cell efficiency with the use of thin metal to reduce fabrication costs. However, this study should also mention other metal that is ideal for the criterion in choosing for increasing solar cell efficiency to compare the percentage on which is higher or lower so other researchers can find an improvement to these metals if the values are low. Furthermore, the use of one type of metal in these studies gives only 17% of increase in efficiency. Future researchers that would conduct the same study on increasing efficiency of solar cell should think about combining two metals for solar cells to get higher the references and the links that are used in this scientific journal. Thank you.